last one here. Find the probability that at least 5 consumers will recognize the name. Well, I want to talk about this a little bit. Is what were our options for these consumers recognizing the name? Well, we had that 0 could recognize, 1 could recognize, 2, 3, 4, 5, 6, 7, 8, 9, 10. We went up to 15 people. So keep on going. 11 was another possibility. 12, 13, 14, or all 15 could recognize the name. On this particular problem, they're asking us what's the probability that at least 5 will recognize the name. Well, at least 5 means 5 or more. The problem with finding that is if you were to just do what we did in the last one, which would be add them all up. 5 or more would include 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. That is a bunch of different binom PDFs to do and add up and hope that you don't make a mistake. So, to find the probability of at least 5, which is the 5 or more, and instead of adding up all of these probabilities and possibly making a mistake, remember I can use complements. What I can do is add up everything but that, which is the 0, 1, 2, 3, and 4. Add up those and then take the complement. I can do 1 minus this. Take its complement. So we'll do 1 minus the probability for 4 or less. Okay. Well, and again, according to my picture, 4 or less is going to include 0, 1, 2, 3, and 4. So the problem is I need to go find this probability first, which means I'm going to be doing, let's see, 5 binom PDFs, just like we did in the last one. Add them all up. Then once I've added them all up, then I'll just take it away from 1. And that will be my value for my probability. So let's take a look at what we get from our calculator doing those 5 binom PDFs. So if we do this one in our calculator, what our calculator points out is we get a 5.5 and then a bunch of numbers, and then we get an E and a negative 12. So remember what that means. That means you're going to jump to 5 and then give 11 more zeros, which means that this whole piece right here is approximately 0. So we're just going to go ahead and just use 0 for that piece over there. For this piece right here. We're just going to say, well, it's close enough to 0. But we were supposed to take that away from 1. So we need to subtract that 0 from 1, that approximately 0 from 1, which gives us that our answer is approximately 1. So it doesn't quite mean that there's 100% chance of it happening, but almost. And it's because that this 0 was almost 0, but not quite. So our probability is almost 1, pretty much 1. Here's another one, and this next one we want to do a multiple choice test, has 4 questions, and each has choices A through E. You have no idea what the correct answer is for any of the problems, so you guess. So we're doing 4 questions, so that means our N for our binom PDF is going to be 4. And just to point this out, we do know it's a binomial distribution again, because when you're doing a multiple choice question, your chances are that you either get it right or you get it wrong. Bi means 2 choices. And the probability also with binomials needs to stay the same. Your chances of getting any question right is going to be the same. It's always 1 out of 5. Your chances of getting it wrong are always 4 out of 5. From problem to problem to problem, that never changes. So what we would like to do is go ahead and fill in this probability distribution. Remember the fancy term, so that we can go ahead and answer some questions. But that means that we're going to have to go ahead and do quite a few binom PDFs. So we'll start out with this first one. finding out what the binom PDF is going to give us for getting 0 correct. So binom PDF, remember, starts out with we near n, which is, according to this problem, 4. And then remember, your chances of success or of getting the question correct come next. Well, if we're looking at what are your chances for getting it correct, remember there's 5 choices out of those 5 choices, how many of them are correct? Only 1 on a multiple choice test, so 1 out of 5, or you can type out 0.2. Remember, 1 out of 5 and 0.2 are the same thing. It doesn't matter which. Your calculator's fine with either. Comma. And then on this first one, we're only looking for what we have from our list, which is, this one's just 0. And then we would want to find out what that probability is, which ends up being, if we use our calculator, 0.4096. Then we'd have to do the same thing for getting not no questions right. We'd want to move on to the next one, which is getting only 1 question right. That next part of the table, getting just 1 question right. So we do another binom PDF. And we'd be plugging in our 4 again, our 1/5, or 0.2. And this time we're looking for just if you get only 1 correct. Can't forget my comma. And again, you get a 0.4096. Again, another binom PDF. And again, a 4. And let's see, the next thing is the 1/5, your probability of getting the question correct. And this one we're going to look at getting 2 correct out of the 4. And the next one, we'd be doing the same thing all over again. So let's do this, and it'd be, except for it'd be a 3. And the next one, same thing again, except for we'd have a 4. And let's see what the probabilities end up being for all of these. Plug these in your calculator. For this first one, we end up with a 0.1596. For the third one, let's see, we get 0.0256. And for the last one, we get 0.0016. And again, if we were to add these up, they should be approximately 1. They might be slightly off due to rounding, but it should be approximately 1. Okay, now just to kind of give you an idea on a test, showing me out these binom PDFs is actually a really good idea so that I can see if you made a mistake, or if you did understand what was going on, maybe you made a calculator typo. So this will definitely help if you show work like this. You don't have to, but it would help. So on this first example, notice, let's see what they want us to find. Well, in this first example, they say, find the probability of getting at least 3 questions correct. Well, at least 3 means 3 or more, which in this case, we only had 4 questions, would mean either you got 3 questions right, or you got 4 questions right, all 4. So I would be taking those 2 probabilities and adding them up, which is the probability for 3 added to the probability of getting all 4 correct, which is the 0.0256 and the 0.0016. And I can add those up, and let's see what we would get. And we end up, once this is all added up, getting up 0.0272. And that's our probability of getting at least 3 questions correct. Let's take a look at one more using the same example, but this time we want to look at getting at least 1 question correct out of the 4. At least 1 means 1 or more, which would include getting 1 right, 2 right, 3 right, or all 4. So the long-winded way that I could do this is find all 4 of these probabilities, probability of getting 1 right, 2 right, 3 right, and 4 right, add those all up, take all those binomial probabilities from my table and add them all up. Or I could realize that the 1, 2, 3, 4 is the complement of everybody else, which is just getting none right, getting 0 right, and I could take its complement. So I could take the complement of just getting none right. So that'd be 1 minus the probability of getting none right. Well, we already have that. The probability of getting none or 0 right from our table is just that first line, that first binomial PDF. So we do 1 minus the 0.4096. And the question would be, what does that give us? So 1 minus 0.4096 gives us 0.5904. Or you can do the long-winded way, which is to take the 1 through 4, what you actually wanted, and take those and add them up. You'll still get the 0.5904. If it is a little bit off, again, it would be due to rounding. The reason why I thought to do complements anyways is because remember what we talked about in that one section? Is it's when you see the word at least. We learned this back in chapter 4, is that whenever you see the word at least, it's probably easier to go ahead and do a complement. Not always, but sometimes, especially when you got this many things to add up, or possibly even more. Continuing along.